Substitution is a method for solving systems of equations that relies on algebra instead of graphing. So when we're done with this substitution, what will we have? What do we want? We want to know what x and y is. We want to end up with an ordered pair. That'll be the solution to our system. First step, we will solve for one of the variables. We'll get an equation that has either x equals or y equals. Next, we'll substitute one equation in for the other. Third, you will now have one equation with one variable in it. Solve it. Fourth, substitute the variable you now know back into the other equation. Step 5, now that you have both variables, write your answer or your solution as an ordered pair. Number 1, here's a system of equations. We'll use the substitution method to find the ordered pair that satisfies both of these equations. Step 1, solve for one of the variables. We want to get either an x equals or a y equals equation. Let's see. I'm going to pick this equation right here. And since that x doesn't have a coefficient with it, I'm going to get the x by itself. So here's step 1. Get x by itself. Divide every term by -1 so that I have just x by itself. Now that I have an x equals equation, I'm going to take the stuff that I know x is equal to and sub it into the other equation instead of the x. So basically what I'm doing is I'm kind of combining these equations so that I have one equation with one variable. Here's how it looks. So I'm going to take this other equation and rewrite it without the x in it. I put parentheses in its place. Now, I know that this stuff is equal to x. So I'm going to sub that in instead of the x. Kind of a neat trick. Now I have one equation with one variable that I should be able to solve. So step 3, solve it. Find what y is. I've distributed. Now I'll add my like terms. And solve for y. If you need practice solving these, let me know and I will tell you where in the videos you can go to find more instructions on how to do this algebra in step 3. So now I know the y. I'm half done. I know the y coordinate, but I still need to know the x coordinate. So here's what you do. You go back to one of the equations that you started with. You could actually use any of these 3 equations, any of the equations that you started with. I like to use this one that I made. And you know that y is 1, so sub that in. Two minus 4 is -2, so the x coordinate is -2. Okay, now I know my x coordinate and my y coordinate, so my last step, step 5, is just to write that as the answer. You show your answer in an ordered pair, the x coordinate and the y coordinate. There's my solution, there's my answer. I could check this by subbing -2, 1 in for x and y into my original equations and make sure that I got true statements. Number 2, solve this system of equations. Step 1, solve for one of the variables. Get x or y by itself. Oh, this problem's kind of nice. I look at this one and I say, oh goody, this one's set up really nice for substitution because I already have a y equals 5x plus 3. That step's already done for me. On to step 2. Sub it in. I know that y is equal to this stuff here. So I'm going to substitute into the other equation. I'm going to put the y stuff in for y. Here's how it looks. I write that top equation without the y in it. This equation lines up right here with this stuff. I've just taken out the y. Instead of the y, I put the y stuff. The stuff that I know that y is equal to. Now I have one equation, one variable I can solve. Step 3, just solve that equation. Distribute. Add like terms. And solve for x. Undo what's been done to x on both sides. Ew, this one's going to be a fraction. That's okay though, I can still solve it. And using the substitution method, I can solve this a lot easier than if I was trying to guess based on the graphing method, where the two lines intersected. I get -3/4, or -0.75. I'm now half done. I have the x coordinate of my ordered pair. Remember, I'm looking for the x and y coordinate of an ordered pair that will be the solution to my equation. So step 4, go back and take one of your original equations, doesn't matter which one, and sub in. I know that x is equal to -3/4. Now I'm going to do some icky fraction arithmetic here. I would maybe be tempted just to punch this into my calculator. 5 times -0.75 plus 3 and figure out the decimal equivalent. But I'll show you the fraction. Let's see, multiplying fractions, it's no problem. First you do the top, then you do the bottom. And then I'll change 3 into 12/4, which will give me a common denominator. So that I can add the tops. -15 and 12 is -3/4. So y is -3/4. Again, if you got -0.75 on your calculator, that's fine. Final step, write your answer as the ordered pair. The x coordinate and the y coordinate. There's my answer. I could plug this x and y coordinate back into my equation for x and y. If I get true equations, I've got the right answer. Notice that sometimes you find the x coordinate first and then the y coordinate. And like in example 1, we found the y coordinate first and then the x coordinate. It doesn't matter. It all depends when you start. If you start with a y equals, you'll find the x coordinate first. And if you start with an x equals equation, you'll find the y coordinate first. Solve this system. We need an x equals or y equals. Sometimes it's hard to know what to pick. I look for an equation that has an x or a y that has a coefficient of 1. That seems to be the easiest for me. I'll take this one. And then just move that other piece out of there to give you x equals 2y minus 7. Next, the substitution step. I know that x is equal to this stuff. So take this stuff and put it into the other equation instead of the x. Make sure to put it in the other equation. You can't put it in this equation. That's the same. That'd be like putting the same equation into itself. We want to put it into the other equation. So write that equation without the x and put the x stuff in instead of the x. So I've combined my two equations. Next, use your algebra to solve this equation and find y. Distribute. Add like terms. Solve for y by undoing what's been done to y. I'm half done. I have the y coordinate, but I still need the x coordinate. So go back and choose one of your equations. I could technically choose any one of these three equations. I like to use the one I made. And I know that y is 3. So I solve and I find that x is equal to -1. So then my answer is that ordered pair with an x coordinate of -1 and a y coordinate of 3. That's my answer. I can check it by subbing in the x and y coordinates into both of my equations. You may have noticed that this equation in number 4 is the same as the equation in number 3. In number 3, we chose this equation and made an x equals equation out of it. I want to show that you wouldn't have to do that. You could also have picked this equation and solved for the y. There are choices in some of these problems for how to do them. I will try to show you the easiest ways and hints for things that I think will make the problem go more smoothly. But a lot of them have different ways that they can be done. So now I've made a y equals equation out of the first equation instead of an x equals equation out of the second. So step 2, sub it in. I'm going to take the y stuff and put it into the other equation instead of the y. Remember, you have to put it into the other equation. So here's how it will look. I'll write this equation without the y, and then instead of the y, I'll put what I know y is equal to, the y stuff. Now that I have one equation with one variable, I can solve. Distribute. Add like terms. And undo what's been done to the x. This time I found the x coordinate first. The x is equal to -1. I know the x coordinate, so I need to know the y coordinate. Take one of my equations from the beginning. Any one of the equations, this one, or this one. I like to use the one I made. Sub in a -1 for x, because that's what x is equal to. Y is equal to 3. So my solution is the x coordinate of -1, the y coordinate of 3. You get the same answer, either way.